right. Well, thank you for coming out this evening. It's nice to see you all here. Everyone in here, I assume, is reasonably familiar with the Thorsen House. Anyone who's really not? I wasn't really planning on doing a lot on the history of the house because that's a topic unto itself, but the William R Thorsen House is one of the four so-called ultimate bungalows, the great masterpieces. It's the last of the four that Greene and Greene designed. The house was built between 1909 and 1910, and it is the only one we have here in Northern California. It has been in a fight with the elements since the day it was built. It's an ongoing war of attrition. You know, in all of our lovely Victorians we have in San Francisco, you get paint that hides things. You know, these houses, as Greene and Greene designed them, nature is so made manifest in all of the materials, the presentation of everything, that there is no room for really bad craft or error when you are repairing them, because first of all, you have to do justice to the quality of the original work, but also there's no paint to hide anything for you. Everything is naked and out there to be seen. And one of the things that was exciting to me about getting contacted about this is that, I don't know if any of you have woodwork addictions, but I think every architectural woodworker out there has a deep love for everything that Greene and Greene did, because these houses are gigantic pieces of furniture. They were built as such and treated as such. And in the case of the William Thorsen House, Thorsen was a lumberman. So quality of wood was not in question. Like, they got to select all of the best, which makes it a real thrill for a craftsman to disassemble one of these things, take it apart, get to lovingly play with it and put it back together. So the scope of the work here, you know, was to replace these four posts. That guy is integral. It's built into the corner of the building, doesn't come out. From here, that way, outside the photo, had been worked upon by Jerry Berkeley, who's out here in this, and I think other volunteers from the house, and Tom Saxby. They have, you know, over the years, the California Sigma Phi Society, who owns the house, has really taken on its stewardship and done a lot of work themselves over the past. So they'd already gotten to what was over there, and now this part needed to be taken care of. So before I go any further with this, I gotta say that getting anything done on a project of this size really takes a village. And I wanted to take a minute just right up front to acknowledge everybody that was a part of this. First of all, the California Sigma Phi Society, which I believe purchased this house from the Thorsen estate in 1943, has been using this as their chapter house here at UC Berkeley all that time and taking care of it, being good stewards of the house. And the team that we got to work with were fun. So we have Thomas Saxby, who's sitting out here. He's the architect. I've worked with Tom before on a project in Alameda, like his style, and he really put together a great project for this. Rick Travers, Rick's not here tonight, but Rick was kind of the house manager and making sure we had access and making sure that information we needed was available. Jerry Berkeley, I put him down as leap of faith, because you know, he's a board member and he's done so much work on this house in the past himself. And he gave us a good look over, like, am I going to trust you guys with this? And are you going to break the bank? I think, you know, were the two big questions. And then Zach Carden was our structural engineer who put together the initial structural element of the plan to fix this. And then my own crew, Matt Borup, my project manager and good friend who's sitting out here, I tend to be in the shop doing the design work and managing fabrication and things in the shop. He's our project manager, handles things in the field. And then my crew that you will be seeing, Nathan Squire, Claudio Munoz, Brian Vortman, Mason Heimberger, Alex Brager, these guys really, really rose to the level of this project. Everybody was so completely excited to be working on it. So, and then we had Steel Core Builders, who's a structural colleague of mine, who came in, because you're going to see we had to shore the whole house up to take this apart and remove all these posts. We did not invent the plan. Tom and the board invented the plan, and so they came to us with a well-defined set of plans showing what our scope was going to be, and a lot of notes and details about what needed to be done, what products we would be using for epoxy, what products we would be using for the finishes in the end, et cetera. And one of the main problems we had with the posts was that they were rotting at the bottom, and they're supporting 3 stories of building overhead. And so this idea of splicing new timber onto the base of each one to hold on to as much of the original historic fabric as possible, that was sort of the driving factor in this. We were completely playing by Secretary of the Interior's rules and guidelines. So these are Tom's photos from before we got involved with the project, and you can see here everything is sort of a kind of a uniform gray, heavily weathered, lots of texture, evidence down here that the bugs or the rot have gotten into the base of this post. You can see these posts consist of a center column, and then there is a buttress held on with these lovely metal straps with the opposing wedges. And then you have these beams that are mortised all the way through, and there's a tenon from this post up into that beam, and this is pinned in, and then there's a whole series of decorative pins and wood plugs and things that hold stuff together. And it became apparent to them that something was going to have to be done because these bases, couldn't possibly be seismically competent in any, in any substantial way anymore. And so by the time we got there, they had done a few bits of homework for us. To get these beams out, because of the texture and the swelling and everything else, they were pretty well locked in there. So they had to do some minor sanding to these beams in order to get them to slide out of those mortises. And they had taken the buttresses off. And amusingly, we found them in someone's bedroom on the 2nd floor when we finally went hunting for them. They were being used as a nightstand. And so these things, in order to come out, part of the problem is you can't lift the house enough to pull it off the tenon that's at the top of the post. So we were going to have to shore the building up, lift it just enough to be able to cut that tenon and slide these posts out. But before doing that, all of these beams had to be slid out, and these corbels had to come out. And it was an amusing situation where this one was so long that you couldn't get it out before it would start going into the mortise for this one or the one on the other side. So we had to kind of come up with a clever plan, which involved getting that guy out, sliding this one into a position between these 2 posts, which you see here, so that once the shoring was done, then we would be able to remove that, slide it in a little ways, remove that post, and then get that guy out. And then there was the whole wash, rinse, repeat in reverse version of this, putting it back together. But you can see right here, I could stick my hand in there and just pull this apart, And it wasn't so much rot as it was damp wood termite damage. They had done a lot. And in some cases, they managed to make tunnels like all the way up into here. But for the most part, it was just like this bottom foot that, was really damaged. So what do you do with a 14,000 square foot house with 3 stories hanging out above this? We talked this through with the structural contractor and ended up building 7 cribbing towers with differing beams. And these all had to be done in a way that they were up out of the way of sliding the cross timbers in and out. They had to be not in the way of pulling the posts out. But they had to support all the different junctures of the beam. And there's a splice in the beam as well here, so we had to make sure everything was held up really well. And you can get a kind of a little better view of it here. So cribbing down here on the yard, up on the terrace, in the covered terrace back here, and this crisscross bunch of beams. And you can see, in here that we were able to still, slide that last cross beam out of there. Looking up, one of the things I loved is that Greene had put these copper flashings on here, and they were still there, miraculously enough. When Signify had removed the buttresses prior to the project, they left the nails in place, left everything there so it could be as minimally disturbed as possible. And these are square copper boat nails, which, oddly enough, I found in a mom and pop boatyard in Rhode Island that they still make these, and they had them. So I ended up getting a bag of these so that anything we had to replace could be done. You see here, we lifted the building about 1/4 of an inch. We didn't want to crack tile in the bathrooms upstairs. We had to be careful, but that was enough for us to get a saw in there and cut the tenon at the top so that we could pull this guy out. Then it all had to go back to the shop. And you can see that this was one of the buttresses that was facing in toward the covered terrace. So it's not textured. It has a lot of a really opaque brown stain that's on it. I mean, a lot of different finishes have been put on these things over the years that weren't necessarily meeting the Greene specification for what color should be. And you can see the ones on the exterior were really, really deeply furrowed and weathered. And the first idea was to do everything in good, conservation fashion with the least destructive, least invasive means possible. So we started out with this biological cleaner D2 and spent a lot of time, we came to affectionately call this toothbrushing, where we're sort of scrubbing and rinsing and scrubbing and rinsing every piece of timber that came out of here. However, there was only so much that could be done, because if you look in here, you can see this crusty residue of old congealed oil finishes and dirt and organic contaminants, a lot of it in here. So even after washing, a lot of it was still like this. So then we had to go to Tom and say, Tom, we got to do more, Tom. And we ended up using some fairly gentle stripping products to go ahead, and we would, put the stripper on, burrito wrap the whole thing, let it sit for a while, and then come back and rinse and rinse and brush and scrub until we get down to something that was substantially cleaner. But at no point did we want to alter the surface texture, because it so blends in with the rest of the building. Plus, it has a beauty of its own that, everything has this lovely weathering to it. So the idea was to get back color and get it clean enough to accept the new stain product that Tom had specified. And without altering the texture, no sanding was allowed. An absolute minimum of mechanical wire brushing with nylon impregnated bristles, no metal. And so I felt like we walked away with something that was substantially cleaner, but in no way really different in terms of texture. And the earlier photo was of the original builders of the Thorsen House, and Charles Greene is standing in the back corner. And he had specified that all of the vertical and timbers below, there's a beam running across that's in the building above. That was supposed to be a darker color, and all of the timber was a lighter, more natural sort of Douglas fir color. So we were really trying to, we knew we'd never get it back to, pristine Doug fir, but we wanted to get that light dark contrast back out of this. Here things are pretty substantially clean. There were some of the ones on the outside. That check right there runs almost 2 inches all the way down into this piece. And so one of the first things we wanted to do, we wanted to bring back color. We didn't want any epoxy on the surface that you would see that would cause problems, but we needed to get those voids filled, because what happens, this is pointing skyward, you end up with water sitting down in there and it just continues to deteriorate. Also, it's a place for bugs to hang out and all that. So we started marking all these little things with dates and times and taking syringes and putting a liquid epoxy consolidant down into these until we had filled them to within maybe 1/8 of the surface. In some cases, we had to tape off the backside because the damage went all the way through and it was just going to run through and out onto the ground, so that we could, get a solid inner fill over which to build the more visible epoxy that we'd be doing later. So that was quite a phase of work. We had a lot of damage, like some of the buttresses, the ends. We just had to take, drill bit and sort of get rid of all the pulpy stuff till we got down to, firm wood, treat it with epoxy, and then using Abitron, restorative epoxy, then filling. And any place that it would never be visible, we let it be its natural white color, but everything else, you'll see in a minute, we started getting out the earth pigments and custom tinting them to match whatever they were going into. And Brian quickly discovered that the stairs were a great place to clamp these things to, so you could work on the ends. There were also things that were just missing. So this whole bottom was gone and some of the face was gone. And we really did not want to be looking at a lot of new wood. So we ended up taking apart some old joists that I'd kept out of a building, beams and things, and cutting and then wire brushing to get a texture in here. And so we built up a core that would fill most of this, fill with epoxy around it, then carefully cut these Dutchmen to go back in and fill in, leaving all of this there. And then eventually, as the process would go on, then I would start fauxing them in so that they look like everything around them. So this is somewhere in that process. And then, of course, there was a whole language of wooden pegs that were, holding tenons in place and things. So we ended up, we needed, the black walnut-colored oak pegs for the beam overhead, and we needed what was the name of the color we used on the other one, Jerry, the lighter color? Cedar tone. We needed the cedar tone, so we messed around, and these have just been dipped in TWP, and we're letting them soak for a while, and then we would wipe them off, and you would end up with a lighter color like this, but we had to have lots of these to go back as things were put together and start replacing the old pins. So eventually, then we went on to these with the TWP, the cedar tone finish, and we would get this. Now, we could have gotten out the oxalic acid and started trying to bleach out the iron stains and other things that were in there, but that was decided just to be a little bit beyond scope. That would have been a can of worms that would have gone on forever. So we all decided everybody was happy with a little bit of tiger striping, to this, but got a lot of color back out of it. And then we started taking the epoxy putties and this and a whole bunch of other earth pigments and mixing them in. And then, this is like a walnut pick we're using here, but basically with dental tools and things, filling in all those really deep checks and cracks with epoxy that matches the local color of where it's at. And then we'd come back in with the tools and a little bit of mineral spirits and smooth it out. And you can see that this is in progress right now. Eventually, this whole thing would sort of be filled in a way that still has all of the wood grain, all of the texture that was there, but we just don't have those deep cracks for water to sit in anymore. Now, back to the posts. So I'm jumping around a little bit in time there, but when they came out, they were sitting on these little tiny stubs of pipe, plumbing pipe, that weren't even all the same thing, that were in a hole in this terracotta pad that they all were sitting on. So you can see that there was no meaningful connection to the ground anywhere, and the post that had settled the must had just this half-inch rind of competent wood, and that was the only thing holding it up. So fortunately, the other posts adjacent to it were doing some of the work to kind of keep it there. So what we had to do was then, really we took a lot of this rotten wood out. So it was, and decided how far we had to go before we could stop. And we came up with this idea as we were brainstorming. We couldn't stand the idea of, even though we found a nice old salvage appearance grade beam that had the same rough sawn orientation of grain and everything as the original posts, it wouldn't match any of these. And it was just driving us nuts, the idea of seeing this splice of new timber down there that was going to be obvious to everyone. So somewhere in the midst of this, Matt piped up with this great idea of, what if we cut the sides, the original sides, off the posts and kept them, set them aside, spliced timber into the center, and then veneered the original sides back on, so it kind of looks like we were never there. So this is, I 3D modeled a lot of things, and so I was just kind of playing with that idea of what you would have to do. You would lose some material in the resawing process, cutting this off, and getting the tenon straightened out on the what's left of the post and on this. So you would have to add some kind of shims back in to take up some of that space. So essentially we're laminating up, we're making a glue lam out of the bottom of this. So to do that, we had to start out with a portable bandsaw. We started out making, first Claudio's making a stop cut here, right across the grain. Then they're sawing the faces off. And you can see here we have the original post sides and this kind of rough stub tenon for the splice that's sticking out. And you can see how much of the rot we've removed from that. And then the guys up here are, cross-cutting the timber splices on this and cross-cutting the splices on the splices that we're going to add. And when all is said and done, you see that, these are the prepared pieces, kind of getting ready toward glue up with their sides, and everything's labeled. So with all the prep work done, you can see here's the side. This is test fit. And then he's just taken this and dropped it down in front of the piece so you can see kind of the little bit of trickery. So the only thing that you see in the end is just this little line for where we did the stop cut. Then moved in with marine epoxy with a good amount of filler. And these were all pre-drilled for SDS screws per the engineer's specifications. And we did review with the engineer this idea. We're like, are we going to still have enough competent wood here if we glue these sides back on? And he said, sure. So then these all got, bolted into there. But at that point, one of the things I should point out that made this kind of such a challenge is that the sides of these posts are not flat. They're not straight. The sides are not square to each other. So no matter what you choose as a reference surface to cut on, you're offending some adjacent reference surface. So we had to basically get these put on here a little bit oversized and then come in and start figuring out how to surface it down to a flat surface the original sides down, hand planing them, getting them ready to go. There would be some filler work in spots where there had been some rot. Get this all chiseled out and set in such a way that when you sit this on here, it's actually in plane with the original post side because you've completely disturbed that relationship in cutting it off in the first place. So, and, Nate's out here with a straight edge, and sitting up on, stickers because it wouldn't sit flat anywhere. You have to sit it up and kind of sight down it and figure out where we'd have to hand plane a little more wood off of that side, to get these things in the right orientation and to fit. And then the aforementioned shim to make up some of the space lost in the reductive process of resawing. And then getting everything kind of trimmed up, everything's oversized. And eventually you get to the point where here's one side glued back on. So you've got the little shim up into here. You can see the original post from here and the tenon down here. But the splice that's on here, these will be hidden by the buttresses that go on, so no one ever sees them. Now, the matter of connecting these back to the building was something else, too. There was no just gluing the tenon back on after you'd put the post back in place. And they needed some kind of competent seismic connection. So we ended up using these Timberlinks connectors that Tom had specified. And basically, you have to bore, you have to make a mortise slot in the side, and then you have a cross bore, and there's this dowel that you slide through once it's in there. And then we put threaded rod up into the beam above and threaded rod epoxy set down into the masonry below. And then this way we could slide the posts on sideways over these connectors, put in their cross dowels, tighten it all down, and then plug these mortises to get them going. So here you see there's the cross bore, here's the cut, and everything's fairly clean. And because there was some rot at the bases, and some of it might be visible, we started coloring epoxy down here and just filling in any little gaps at the very bottom of the sides that had been glued back on so that you wouldn't know we were there. Then all of these things, of course, again, you can't pre-cut anything. We cut everything a little oversized, glue it on, and then trim it back to fit because, again, there are no square or normal reference surfaces on anything. So Nathan's just, block planing that back so it's flush. Then back at the site, each of these sits on a little terracotta pad that you have here. And so epoxy set threaded rod into that. We had to plug the old tenon, the old mortises for the tenon with a piece of wood and epoxy, and then drilled way up past that and epoxy set threaded rod up above. And then while the cribbing is still there, then the guys slid all the posts back in. And you can see here, looking down at the bottom, here it is, sitting on that timber connector, and this is the plug that will go in there for that, top and bottom on all of these. And this is what you would see from the other side of this. Here you see the lower portion of the splice. Here you see the whole length of it, as you know, these splices ended up being about 30 inches long. Small variation depending on how much rot we had to deal with. One of the 4 posts did not need anything spliced. We were able to just fill minor damage in the bottom and put it back in. And at this point, you're starting to get to see what things look like when they're substantially clean and have some color. Douglas fir turns very orange when you put any sort of an oil-based finish on it. And so any plugs like you see here and here, we went back in and then colored them in to match, to blend them into everything else. And the guys, put the buttresses back on. This is after the posts were in, the shoring was removed. Then the buttresses went on, the cross beams went back in, the corbels went back in, and you can kind of see just how clean everything ended up. This is one of those original flashings nailed back on with a row of slightly longer correct period nails for that. And you can see here, this is one of those tops that was highly corroded that we did put a lot of effort into doing what I hope isn't a very obvious epoxy fill. And then back in, and you can kind of see the end results. This has that dark color up there. And now there's all the rest of this around here that somebody has to deal with. So one of the things about this, to me, it was a striking project because it wasn't just an aesthetic component, it was an actual seismic structural component. And we would have all been absolutely sick to go and replace these posts, or even sick at heart to leave the splices exposed for you to see, because it's kind of reaching back. It's like having a time machine to kind of reach back, try and take this thing back toward what the original builders had done, what they had intended, and to see that this, house 130 years in or whatever is still sitting on mostly the same wood that it was been sitting on all along. And so I'm hoping to do a little bit of advocacy for the California Sigma Phi Society as well, not only in recognition of all the efforts you guys have put into stewardship of this house, and it's a never-ending battle, right? It's a 14,000 square foot L-shaped house. Like, there are so many surfaces to deal with, so many rafter tails, so many beams. It's constant fundraising, I'm sure, at all times, to pick the next project amongst all the projects, choose the priorities. Oftentimes they're structural. Anything seismic, will come before aesthetics, and or what is really going to fall apart next, right? And so they've got their work cut out for them. And and I'm really hoping that if there's anything I can do to help with a fundraising campaign, because this is one of the greatest works of vernacular architecture in the United States. And to see that it goes on in perpetuity, it's like the marvelous things that I've seen that the Hillside Club has done with this house, or this hall, over the years. And and I am pleased to announce that as part of that effort to do a little advocacy, I submitted this to the California Preservation Design Awards, to the California Preservation Foundation, for the 26 awards, and I just got notified on Thursday of last week that we in fact did win. And so that's really a testament to everybody's efforts that we're willing to just go. So California Sigma Phi winding us up and letting us go and taking that leap of faith, because it was kind of a ambiguous stopping points. Where does this end? How good is good enough? All those questions you get into with old buildings. But it's a testament to their efforts, and I think also a testament, I really just huge shout out to my crew for all of the neurosis that went into putting these back. And so in a way that this is our main goal. We're old house mechanics. We want it to look like we were never there. And so that was, I take the objectives as pretty well achieved in this, and hope to go on doing some work in the future. Would you gentlemen like to say anything about fundraising, websites, efforts, or anything else?
Yeah, I think that we can all kind of bow our heads to the mastery we've just witnessed that Chris and his whole team have accomplished to achieve what's shown here. I do think actually that this assemblage of posts and beams and the different elements and the straps are probably the most significant individual elements of this house. Some could argue amongst maybe most all of Greene Brothers' work. So to have invested that kind of skill and determination to achieve this is really remarkable. And Chris is right, it was a leap of faith. I mean, Tom and I are both graduates of the architecture school at Cal. I was a few years ahead of Tom, and have done work on the house. Back in '78, we did a pretty substantial exterior reworking of a lot of exposed beam and rafter ends and replaced many of them. So we are now, and we've done a lot of things over the years, not enough. And the funds needed to do a complete restoration are pretty staggering. But we have become more organized in the last year or so, and we're beginning to succeed in attracting donors. And we are definitely going to continue our efforts to try to preserve the house in terms of its exterior aesthetics, to add seismic strength to the building, and to just maintain the infrastructure to support a lifestyle of students who are really the core of our purpose. It is a fraternity, we're proud of that. And we have been the stewards of this house for good, or sometimes not as good as we could be, for far longer than the Thorsens owned the house. So it means a great deal to us. It's our home. We think of it in those terms. And so we certainly want to do a lot more. And the priorities are challenging. I can't give you a website at the moment off the top of my head. I should have been more prepared in terms of how you could, Tom, go right ahead.
ThorsenHouse.org.
It's as easy as that. ThorsenHouse.org. And
there's a donate selection at the top of the page. You can follow that, and it's a 501c3, so it is tax deductible donation.
That's right. That's an important consideration for a lot of people. I wish it was a consideration of mine, but it's not my tax bracket yet. But it is important to many people, and that is available. Even if that doesn't mean too much, we also have to fund other things that those tax-deductible funds can't be used for. So the California Preservation Foundation holds an exterior easement that we entered into with them a little over 20 years ago, 25 years ago. And so we have to get their approval for anything we do to the areas of the easement, which includes the entire exterior of the house as well as the grounds, and the primary important rooms on the ground floor and the stairwell to the second floor. So there are other things we need to do that aren't within that easement, so any money through whatever channel is appreciated. So that's probably enough for me. I just want to thank Chris again and Matt and their whole team for doing such an extraordinary job. I was around to see it happen and appreciated it as it was happening, but to see this presentation really puts it into a context that it gives me a whole new appreciation. Thank you, Chris. You have a question?
All right, if,
House periodically with public, you know, to come and see parts of the area.
Can someone repeat the question so we can hear it back there?
The house, generally speaking, is pretty accessible. The students are extremely proud of the house, their involvement with it, and most of them, if they're not busy getting ready to go to class, will show you around to some extent. Some are more knowledgeable than others. So we have not organized much in the way of public gatherings, but really it's pretty casual, and you know they're pretty receptive if you knock on the door and say, "Yeah, I'm a fan of Greene and Greene, love the house, and can I take a look around?" They will usually accommodate you.
Chris, could you just give us a little bit more information about the timeline and budget for this work?
Well, the timeline. Matt, what were we on this? Maybe, was it 5 months? It was all a blur. You know, one thing I should state is that I've glossed over a lot. There was a lot more going on here, but I didn't want to like exceed my time and get thrown out by the management. And the budget, I honestly don't know. In terms of an exact number, but you know, there you go. Yeah. Well, we start, you know, so I'm a strictly time and materials company because I'm asked to do unbiddable things all the time. And there was you know, that was part of the leap of faith because there was a lot of dialogue back and forth about that. And we came up with an initial estimate based on what we thought we might be doing. But you never know what you're going to do on a project like this until you start tearing it apart and you find out how bad the rot is or, you know, little problems that come up along the way, you know, that you're going to have to deal with. And so, and some of the solutions, you know, we knew we were going to splice new bottoms onto these posts. We didn't know we were going to come up with a clever way to hide them at the beginning, you know. And so all of a sudden there, well, that's kind of an additional bit of scope, but well worth the effort. And everybody agreed upon that, right? So most of these projects are very much a discovery process, which is why you have to be a person who likes puzzles to do them because you really are going to figure them out in the doing. Yes, sir.
So you mentioned a terracotta that you're putting them under the footing.
Well, those footings are, it's a terracotta pad. It's not really the structural, this is all masonry underneath, right? So that, you know, it's masonry with a veneer of brick and terracotta tile on top. So we were, you know, putting them back on their original terracotta pads. We didn't move those, but the Timberlinks connectors and the threaded rod were all down into the foundation.
Which was pretty
Substantial,
substantial.
yeah, enough. I mean, you know, there's one of those things, that's another one of those questions is like, how perfect is perfect enough? Did you need to report that whole thing to know, right? I should add that, by the way, it was like 2 weeks after we finished this, there was an earthquake on the Hayward Fault with its epicenter like 2 blocks from the house. Just missed that one, yeah. Yes, sir. Very good question. So, depends on the kind of bug. They all have their different tolerances for moisture levels and, you know, what they can and cannot eat. And most of them will not deal with something that's well sealed. They don't like to chew their way through a layer of oil or epoxy or something else. So, first of all of the bases where you can't see them are heavily epoxy treated. So this business of getting up from the bottom. The other thing is that there was a big cavity. There was like a big hole in the middle of that terracotta tile that was just like a moisture sink, and the little pipe was sticking up out of the middle of that. We filled those to the brim with epoxy. There's no place for them to hang out. I actually, this post, I think, no, the next one over, that one, the termites had gotten all the way up into the mortise for the crossbeam, and we ended up just standing it up on its end and just pouring stuff down through all of those tunnels. So it's pretty inhospitable for anything. It'll take them a long time to get a toehold back in this. And we just all know that the California Sigma Phi Society is going to be absolutely Johnny on the spot with keeping these things regularly coated with TWP, so that discourages the bugs as well. So, yes, ma'am.
You mentioned the recent earthquake, and since the Thorsen House sits essentially on the Hayward Fault, curious when you were,
Not really.
which is wonderful, and
That house is so well built. It's pretty rock solid.
you need to accommodate, say, future movement with adjustable.
No, I mean there's enough flex in the system for a reasonable amount of this stuff going on, right? You know, the thing is that this is one spot on an enormous building, and they've already done some. You know, there's areas where they've bolted the foundation. That may be a future thing we're looking at with the western facade, is bolting that line to that foundation, which will be, of course, predictably really difficult thing to do. But yeah, it's Riley. I was doing all of the fauxing in of color with mineral pigments, earth pigments, right in the glazing them into the TWP linseed oil based semi-transparent stain that we were using. So I could come back over with the same thing and put it in, and earth pigments they don't fade. So it may be more of an issue of everything around it fading versus, you know, where some things have been patched. Yeah, it's, you know, I'm big into the use of mineral silicate paints on cementitious buildings, stucco buildings, things like that too, because same thing, they don't fade over time. But no matter what, UV is our enemy. UV and water, right? Eventually things will look different. But depending on how often they go out and recoat these, because the idea here, you know, you can do a varnish that is going to be good for a while, and then it's going to be catastrophic to fix, because varnishes don't adhere to varnishes very well. Eventually it's going to crack, it's going to chip, it's going to degrade, and then you're going to have to strip it all. So the idea of with this sort of oil-based finish is that you can periodically go in and renew it, just keep coating it, and it's, you know, you're trading, you know, lower difficulty periodic maintenance for longer term catastrophic eventual maintenance is just the way it goes. But so, yes, sir.
How did you, those extra pieces on the ends, are those tenon in? Do you have to cut them?
Oh, those little corbels that are up there. Those little, we called those the whale's teeth because they just looked like came out of a whale's mouth. They, in some cases, like the one you see closest to us, we never took it out. We just left it tenoned into the beam because we didn't want to destroy that. But before we got there to play with sliding the beams out, Sigma Phi Society had cut the tenon on the bottom. So some of those now have hidden screws up through the hole the pin is in, so you'll never see it, and then the pin is hammered into that because there's no way, you know, obviously the building got built from the bottom up, and you can't take that apart enough to do that. And, you know, it's funny, that little bit we jacked it up, which was maybe 3/16 of an inch, ended up causing drainage problems in one of the bathrooms on the second floor, right? So you got to be careful what you do. All right. Any other questions? Oh, yes, sir. I am an old building mechanic. I don't care what it is. You know, we're 4 phases deep in a 1937 Richard Neutrum modernist house in San Francisco. We do a lot of Victorians. We get typecast for that because that's mostly what we have. And then we work on arts and crafts buildings. If it's an old building with an engaging problem, that's really all that's required. And then we have Riley sitting over here who can tell me anything about terracotta I need to know. All right. Well, thank you for coming out.